Hello everybody, this is Dr. Dick again, and this is I'll talk today about chapter 2. Chapter 2 is presenting the basic laws in circuits. You can solve any circuit. Solving any circuit, that means that you can calculate the voltage and current for this circuit. Okay, if you know these three laws, only three laws, very easy, three laws. But of course, when you have a more complex circuit, it will be very difficult to solve the circuit using these three laws. That's why in chapter 3 we'll learn a technique, very easy two techniques to solve any kind of circuits. It doesn't matter how big it is. So what are these basic laws? First, before I start these basic laws, let us make some definitions. We have something called branch. Branch, if you have a circuit like this is a branch. You can consider this 50 example ohm. This element is a branch. This one is a branch. This one is a branch. This one is a branch, and so on. Also, you can consider a branch any elements like this one here, this two, from A to B here. This one is a branch. Let me turn on the laser. Okay, so this one is a branch from A to B. It's a branch. Okay. Why? Because the current does not change in this branch. Same here. This 70 and 20 branch. This 50, 20, 120 volt, the branch. This all one branch. So branch, you can consider any element a branch, or you can consider any elements in series branch. Series means the current does not change, means that they are connected from one side and the current does not change. Like again, from A to B, from this one to this one, they are one branch. But you cannot say, for example, that these four elements are one branch. You cannot say that. Why? Because the current doesn't change here. The current change. There is a difference between the current in this one, the current in this one. There is a node, something called a node. Any intersection is called a node. Like this one, this black node, this red node, black, red, black, black, and so on. Any intersection between two elements is considered a node. So the node is any intersection. So now what is the difference between this black node and red node? The black node is the regular node. This is any intersection between the intersection between any two branches. Okay, but the red one is the intersection between three or more. Okay, and this is called also dividing point. Dividing point. So if you have a node like this A or this B, you have three or more branches intersect, and in this case you have the current will change. This is a dividing point. So let us, for example, see if we have a current in this branch. The current here assumes that this is I know that the current here is, for example, 3 ampere. So the current in this 20 will be 3 ampere. The current is this 50 will be 3 ampere. Okay, now at A the current will be divided. So this 3 ampere will be divided between these two branches. Okay, so let us assume that the current here, for example, is 1 ampere. What about the current on the other side? Will be 2. Because if this is 3, then it will be 1 and 2. 1 and 2. Makes sense, of course. Okay, so if this current is 1 ampere in the 40, the current in the 20 will be 1 ampere also. Okay, and here this is 3 ampere. If this is 2 ampere, this one will be 2 ampere also. And then you will find a point here that this is a dividing point also. What happened? That the current in this branch will add to the current in this branch, and then will make 3 ampere again. Then this 3 ampere will continue again in the same branch as it started. So 3 ampere, and then will be divided, and then return back 3 ampere, and so on. So this is a difference between the black and red, the black node and the red node. So the dividing point is very important. We need to know that if we have any dividing point, we have a current change. But if we have a node like this one, just intersection between two branches, or two elements, this does not change the current. Loop. What is a loop? Loop is a closed path. Okay, so for example, in this circuit here, look at this one here. This one. How many loops we have here? Okay, if you want to start from A, for example, you can go from A to this black node, to this red node, to this black node, and return back to A. So this is a loop. Makes sense. From the name, the loop is a loop. Here it is. You close loop. You see? Also, you can have another loop. Like for example, if you go from A like this to B, and then you continue this branch, and you return back to A. This is also a closed loop. Or you can go from A to B through this branch. Okay, and then you continue like this. So this is another loop. Another loop. So how many loops you have here? 3. And you can see these loops here. You can see these loops here. Okay. Okay. So yeah, this is just two of them. Okay. So these are example of loops. We have also different kind of loops. We have a loop that's called mesh. So the mesh is a special loop. Mesh is a special loop. The mesh is a loop that does not have internal loop. Does not have internal loop. Like for example, this one is a mesh. This one is a mesh. And this one also is a mesh. Okay? Why? Because they do not have loop inside it. But for example, the outer one here, outer loop, is not a mesh. Why? Because it has a loop inside it. Maybe it will be more clear here. For this example here. If you look at the outer loop, okay, from here, like this one here. This is a big loop here. So you start from this black, going in this direction, for example, and going like this, and continue like this. This is a loop, right? But is this a mesh? No, it's not a mesh. Why? Because it has a lot of loops inside it. It has this one inside it, this one is inside it, this one inside it, and so on. So the mesh is a loop that does not have meshes inside it. And it is very easy to count the meshes, but it's a little bit tricky to calculate the loops. For example, here you have 3 loops. This one here, you have 3 loops. But how many meshes? 1, 2, 1, 2. Here, how many loops? I have to start here. Think about it. But how many meshes? 1, 2, 3, 4. It's very easy. Very easy to calculate the mesh. How many loops? You try to think about it. Of course, this is a loop. This is a loop. This is a loop. This is a loop. So you have 4 loops now. Okay? But also, this one here is a loop. This one here is a loop. This one is a loop. And this big one is a loop, and so on. So you have many loops. You have many loops. You have more than meshes. The loops are more than meshes for sure. Okay? But the meshes are easier to count. So this is a difference between the definitions of branches, nodes, loops, and the meshes. The basic element, as I explained in chapter 1, this is a resistor. One of the main basic elements is resistor. And resistor is the element that resists the current. Okay, it's a passive 2 terminals electrical component that resist currents, and it is measured in ohm. Ohm. You see this sign, this symbol here is called omega or ohm. Call it ohm. And there are many kind of resistors. Like for example, this is a standard US standard. So this zigzag line means the resistor, or international like this one, rectangular like this. So any one of them is working. That's fine. But if you have an arrow like this or like this is called potentiometer or variable resistor. So this resistor does not have a certain value. It's not 100, it's not 1000. No, it is variable. So you can change it. This is exactly like a knob. It's a knob. You see, as you see here, it's like a knob. And this is the ones that we were using in some radios, for example, when you try to tune something or change a volume. This is a device that is used for that. So you just change the resistance. And these are some examples of resistors. So this is a resistor, for example. This one is a resistor. Some of them you can read the value. Here, for example, this one is 4 ohm. This is 4 ohm. Okay, 10%. This is the tolerance. Tolerance means that okay, it is 4 ohm. Yes, this is what's read, but it is designed that it is not very exactly accurate. It is 4 ohm, but it has a 10% color tolerance, which means that it is plus or minus 10% of its value. There is an error in this one. That's 4%, 10% of its value. This one here is what? This one is 180 ohm, 180 ohm with 5% tolerance. And here say 4 watts. So this is the maximum watts, well, maximum power. Otherwise, it will burn. These resistors here does not have value, but you can read them. You can read them, and the reading resistor is not a big deal. How can you read a resistor? Each color has a value, like this. For example, you see here in this branch, in this table, the black is 0, brown is 1, red is 2, orange is 3, and so on. Each number has a value. Okay, so imagine that you have, for example, this resistor here, this one here. So how can I tell what is the value of this resistance or this resistor? It's very easy. You put the number of the first one. So for example, this one is black, so this is 0. Second one here is red. Red is 2, so it is 0, 2. The third one is number of zeros. Number of zeros. That's it. So it will be what? It will be 0, 2 times what? 10 to the power of 5, or 5 zeros. You can say that. 5 0, or 10 to the power of 5. Okay? So it will be 2 times 10 to the power of 5, which is 200,000. 200,000.